Hi guys, this is section 11.2. This is our last section for statistics. I'm making a big hooray gesture with my arms that you can't see, but I hope you can picture that. I'm very proud of you guys for working all the way through this class. So this is the last section and the last video. Section 11.2 chi-squared tests. So chi-squared tests are looking at relationships between two qualitative or categorical variables. So here's an example. On page 580, this is question 31, and it's looking at the gender gap on campus. Question reads, much has been written about the gender gap in the electoral process. Okay, Kate adds, yes, well, I haven't read any of that, so not a lot has been read about it in my mind. Is there a gender gap on campus? And it says a random selection of 500 students were selected from one campus and their gender and political party were noted. So I'm going to kind of stop it here for a second, and if this was a question on the final and it said, what test should we use? You would know this was a chi-squared test. How would you know? Because you're looking for a relationship between gender and political party affiliation, right? Like that. That didn't make it very red. And both of these variables are qualitative or categorical variables. So you should use a chi-squared. Obviously, this is in the chi-squared section, so you figured that out. But on a test, your tip-off that this is a chi-squared is you're looking for a relationship between two qualitative or categorical variables. So, and you see this test using significance level of alpha equals 0.01, whether a gender gap exists. That is, whether or not gender and political party preference are independent. This confuses me. The question wording is a little odd because I wouldn't describe this as a gender gap per se, but I think it's relevant to say, okay, well, let's see if gender and political party are independent or whether or not there's a relationship. What they're sort of dodging is they're basically trying to see, are more men Republicans, are more women Democrats? That's the stereotype. So that's what they're trying to get around in this neutral statistical way. Are gender and political party affiliation dependent or independent? So here is the data. They give you a chart that looks like this. They give you the row and column totals here, but I'm not sure if you're using the calculator, you won't need them, so I put them in red. This data looks a little bit doctored if you ask me, because look how clean and even it is, 150, etc. So I'm assuming this is somewhat fictional data or selective, but we can do the test regardless. So here's how you do the test. Step 1, you set up your null and alternative hypothesis. So the null hypothesis, H0 and HA, for the chi-squared tests, we're looking for this one. If you go back to the test, you're looking to see if there's a relationship. Gender and political party are independent versus dependent. So the null hypothesis is always independent. So the null hypothesis is gender and political party are independent. You have to assume that there's no relationship until you have proven that there is one. Independent. And the alternative hypothesis is that gender and political, doing these hash marks, political party are dependent. And yes, you can do this on the final. You can write the little hash marks. I get it. You don't want to do all that extra writing. So that's the null and alternative hypothesis. Step 2 is we need our test statistic. Something wrong with my little thing here. You need the test statistic. So what I'm going to do is show you how to find the test statistic. You need a test statistic and a p-value on the calculator. I'm going to go through the whole thing showing you how to do it on the calculator, and then at the end I'll show you how to do it by hand, because I think most of you are going to do it on the calculator, and I don't want to drag you through the by hand part unless you're one of those people. So on the calculator, here's what you want to do. Here's your data. So first you have to enter all this data into a matrix, which if you've taken a linear algebra class, you know how to do this if you had your little calculator then. So you do second function matrix, and then arrow over to edit. So you're going to go over to edit and hit enter. Okay. And then it's going to ask you, what is the size of your matrix? And it goes row by column. Think RC, remote control, row by column. And you count the rows. There's 1, 2 rows and 1, 2, 3 columns. Notice I don't count the total. We're not including that. 2 rows, 3 columns. So it's 2 by 3. Okay, so you hit 2 by 3, and then it should give you a little matrix there, and then you arrow down and just enter all of the numbers. So you're going to enter 100, then hit enter. 50, hit enter. 100, hit enter. 50, 100, 100. So you're going to type in these numbers, and when you're done, it should look like this little matrix here. Most students, this part, entering the numbers, is not super hard. So when you're done with the last number, 100, you are done entering all the numbers. Now we're going to do the test. So hit stat, the stat button, and then arrow over. You have to use the arrow key to get to tests. I'm assuming you're doing this with me. Why am I doing this by myself, you guys? You have to do it with me. And it's down here under C, the letter C for Charlie, or chi-squared. You have to go down a bit to find it. And then hit enter. And the nice thing is at this point you don't really have to do much, because it says, it gives you something like this. After you hit enter, it says observed, and then it says like this, A, like that. And that's saying that it's the data that you entered is in matrix A, which is data is in matrix A. You just put the data in matrix A, so yes, your observed count is in matrix A. That's good. And this other part that says expected, and then it looks like this, right? B, that's telling you that the expected counts will be in matrix B. So that's just what the calculator's doing. But for the most part, you can just kind of, if you're going fast, you can go down to calculate, hit enter, and it spits out this number. It's so fast, you guys, it's crazy. The calculator should give you 33.33 for the chi-squared. That little chi-squared, I should make that squared. That's the test statistic. I got a p-value of 5.7 times 10 to the negative 8. That's basically 0. This is your p-value. And degrees of freedom of 2. And you don't need to worry about the degrees of freedom if you're using the calculator. So, your test statistic, let's go back here, filling this out, you want to write the test statistic is 33.33, and the p-value is basically, you can write it like this, 0.0000. And if you're doing this on a test, you can write from calculator. These questions, these chi-squared questions, you will not have that much writing down if you're using the calculator. So then you need to include a conclusion. You can't stop there. So here's your conclusion. The p-value is less than the alpha level. That's always the rule. Then we reject H0. So we're rejecting H0. That means we're going with this one. Sometimes I make an arrow to indicate which one I'm going with at the end. HA. You have to include a sentence though, you can't just write an arrow. We conclude that there is sufficient evidence, this is awkward, let me write it like this. There is sufficient evidence to conclude that gender and political party affiliation are dependent. Notice we're stopping there, we're not saying, therefore all men are Republicans, darn them, or all women are crazy bleeding heart liberals. You don't add that much opinion. You're supposed to keep it really neutral and say there is sufficient evidence to conclude that gender and political party affiliation are dependent. And you stop right there and let the comments flow in from your radical study. So, thus ends how to do the chi-squared test with the calculator. For most of you, you want to stop here watching the video, unless you want to do it by hand. Why? Why do you want to do this by hand when your calculator will do it for you? I don't know, but I will walk you through the steps if you're curious. But again, you do not need to do this by hand. It's just, here I go. Okay, hold on, I'm going to draw a new picture. Okay, by hand. And of course you're using the calculator a little bit, but you're not using the fancy calculator function for finding a chi-squared test. So before you can calculate the test statistic, you have to find the expected frequency for each cell. So the expected frequency is the row total times the column total divided by the grand total. So let's start here. I will use yellow for expected. Yellow equals expected. So for the first one, if we look at this one right here, the expected count for the female Democrats is the row total, so it's 250, times the column total, which is 150, divided by the grand total, which is 500. And that gives me, wait for it, 75. So the expected count is 75. And you do the same thing for each one of these. For 50, for Republican females, it would be 50 times 250 divided by 500. You'll notice these numbers work out such that the expected totals, if you do these one at a time, you'll notice it's always 75. It's because the row totals and column totals, look, it's 250, 250, 500, 150, 150. So 75. Okay, 75. 75. Oops, how'd I get? I want yellow. I want yellow. Wait, I'm wrong. This one should be 100. 100. Why is that? I want it yellow. Yellow, I say. There we go. So these are our expected counts. So we're not done yet. So I just said I would expect to have seen it lay out like this. If there was no relationship between gender and political party affiliation, you would expect 75, 75, and 100, 75, 75, and 100. That's what you would expect. So we just found the expected counts. Now we have to find the test statistic. So this is the formula for the test statistic. It's the test statistic, chi-squared, is the sum of every observed minus expected squared divided by expected. So the sum of observed minus expected squared divided by expected. We go back. Okay, I'm going to do this in cherry blue. So the chi-squared is going to be the sum of every observed minus expected. It's hard to make these E's. My pen is not that responsive. Squared divided by expected. This is how you do it. You start with the first one. That's this one. So the observed is 100 minus 75 squared divided by the expected, 75, plus the next one. I'm going to go this way. It doesn't really matter the order that you go in. 50 minus 75 squared divided by 75, because that's the expected count for this one, plus, I go to this one, 100 minus 100, oh good, that's going to be 0, squared divided by expected 100, plus, you see you keep going, I'm running out of room, you do that, this one and this one, you do it a couple more times, then you get to the last one here, which is 100 minus 100 squared divided by 100. You'll notice I didn't include these two because those would go right in there. Okay? Hold on. I'm going to do these all by hand and let you know the numbers I came up with. Just a minute. Okay, a little math. Didn't take me that long. That was like a minute. Ha ha ha. How long did it take you guys? I thought so. Okay. So this first one is equal to 8.33. That represents this guy. Plus, this one is also 8.33 plus, this one was 0, 0, plus, this guy was, did you think it was going to be 8.33? You were correct. And you have one more. You'll notice it's because the difference is always 25 and the expected value is always 75. 8.33 plus, this one's 0, because it's 100 minus 100. So you basically get 8.33 times 4, which is 33.32. 33.32, which is the same thing we got from the calculator. The calculator had more room for rounding than we did. So that gives you, that's how you find the test statistic by hand. It's quite challenging to find the p-value by hand because we don't have a nice p-value table for this chi-squared test because we have different degrees of freedom for each chi-squared. So if you're doing it by hand, you have to use a chi-squared You have to use the table in this funky way, and I may make a video about doing that, but I really don't recommend that you do that, you guys. You're going to get a p-value interval, which is sort of tedious to work with. So I'm going to stop here and say, by hand, you can get the test statistic equal to 33.32, which is close enough, and the p-value, you must use the chi-squared table. I know I spelled squared wrong, sorry word, which will be another video, but it's not recommended. There, how's that? I'll fix the chi-squared. You may all sleep easy, that is spelled correctly. Alright, you guys, I really expect you to do this on the calculator. It's much easier. Alright, see ya.